Hey, welcome back to the series. In the previous episode, we have seen how to install Node.js through NVM. In this episode, we are going to see what are all the things that we need to install or we need to learn to build this stack. So this stack mainly comprises of four things. One is PostgreSQL, which we use for the database, and the Express.js, which is Node.js web framework, and the React to build user interfaces, and the Node.js where the server-side environment to run your application. So this is one of the popular choice when you are building full stack web applications. And with these four key technologies, we can build end-to-end web application, and we can deploy anywhere. So so there are so many things that we have to install to build this application, and we need to go one by one. And also we will see how to develop in our local environment, and also what it takes to build for production. All these things we will cover in the next episodes. And let's see while development how we can actually run these different parts of the application. So we have PostgreSQL, which is the database which we are running on port 5432, and Node.js API, which runs on port 5000. And finally, we have web UI, which is built with React, that runs on port 3000. So here you can choose the ports, but these are not the default ports. But PostgreSQL port is by default, it uses 5432, and Node.js API you can choose any port. And for the React UI, when you build the application through any React CLI, it chooses the port 3000, but you can choose the port. So basically all these applications will be running on different ports in development, so that way the development will be faster. And let's see how we can run all these applications in development environment. If you look at this image, we have 3 services running on different ports, and we can access this web application, this full stack web application, on the browser through localhost 3000. So that means whenever the user hit this localhost 3000, the request goes to the React application. So when we run our React application in development, we run with Webpack Dev Server. So what the Webpack Dev Server does is it watches all the files. Whenever you make any changes, it watches all the files and it reruns the entire application, so that you don't have to restart every time you make any change. So with the help of Webpack Dev Server, you serve your React UI to the browser on the port 3000. And also whenever the UI needs any data, it will make an API call over REST API to the Node.js API, which is running on port 5000. So in the Node.js API, you have a configuration or driver configured to talk to the PostgreSQL tables, so that it can make all the CRUD operations. It can read the data, it can update the data. So all those things you can make through Node.js API. So your backend is running on port 5000 and your front end is running on port 3000. There should be some mechanism so that these two services running on different ports should communicate with each other. So for that, React CLI provides a option called proxy, so that you can configure proxy object in package.json, so that whenever you need any data from the API, you can proxy all those calls to the backend API. So for example, if the user hits for example, if you configure the proxy with /API, so all the requests that is coming from the web that starts with path /API will be forwarded to the Node.js API, which is running on port 5000. So that way, the user, whenever the user hits any data from the API, you can proxy all those calls to the backend API. So That way, the React communicates with Node.js REST API in the development environment. But while in the production, you don't need to proxy. You don't have to proxy. All you need to do is you run the Node.js API and you serve all the static assets of the React application through Node.js API itself. So we will do that as a separate episode later. But for now, in the development, all we need to know is your front end has to run on a different port and your back end has to run on a different port, and these two communicate with each other through proxy object. So the whole development environment can be achieved through Docker Compose as well. So sometimes you might not have all the tools or applications installed on your local machine to run the whole local environment. So in those scenarios, Docker Compose comes to the rescue. All we need to do is you need to have the Docker Compose installed on your machine. All you need to do is you have a Docker Compose file where each application as a service, and when you run the Docker Compose up command, it runs all these applications as a separate services, and these services can be communicated with each other on a Docker bridge, and also this is really useful when you need to spin up a local environment quickly and debug the application. So here is an example of front-end service from the Docker Compose file. Don't worry about the names. You can check the ports, and you can name the container, and also you can mount volumes, and also it depends on the API. So this is just an example of the front-end service in the Docker Compose file, and let's look at the backend. So here is the backend where it has its own Docker file, and also it runs on the port 3080, and it has the container name and the network where it runs, and the volumes. This also depends on the DB. So don't worry about the syntax. There is a separate episode on how to run this stack on Docker Compose. So here is an example of PostgreSQL service. So the DB, you can see the environment variables, and you can see the port that runs on 5432, and we have a volumes as well. So that way you can start the whole application with single command, which is Docker Compose up. With the Docker Compose down, you can destroy the whole environment. So all these applications running as services on the same network so that they can be communicated with each other. If you look at this diagram where all these services running on different ports can be communicated with each other and serve the whole application on port 3000. So whenever the user requests data, the request goes to the front end. Whenever there is a data needed to the front end, we can proxy the call to the service, since those services are running on the same network. And in the same way, the Node.js API talks to the database, and it reads from the database, and it serves all the data to the front end. So the whole development environment on Docker Compose can be run very smoothly as you are running everything on your local machine. And let's see how to build this and put it into production. So when it comes to the production, you don't need to run as a separate services. All you need to do is first you need to build your React application and convert the whole React application into static assets. You need to put those static assets of front end into the public folder. So what the Node.js API does is the API serves the whole React application, which is the front end, from public folder, so that when you hit localhost 5000, it loads the index.html. So the index.html has all the React code in it, So whenever the index.html is placed into the DOM, the React kicks in and it displays all the components, all the HTML. So whenever every request goes to the Node.js API first, and then it will look for all the API routes. If nothing matches, it loads the index.html again and again, so that React will take care of all the routing in the front end. So we will have a separate episode to build for production, so don't worry about it, and we will see how it we will see step by step. So there are two ways to build and deploy in production. So one way is to zip the whole thing. First you build the React UI and put that React UI in the public folder of Node.js API, and you build the Node.js API through Webpack, and you put all together in a zip file and deploy the zip file into any Node.js environment. So that is one way. The second way is you can Dockerize the entire thing, and you can run this, you can build an image, Docker image, you can deploy this image anywhere, wherever there is a Docker runtime available, and you can run this stack as a container. So when it comes to the Dockerize PERN stack, you need to follow multi-stage builds. What it means is, for each stage you build, and you take the assets, you take the build from each stage and put it in the final stage, and you create an image out of it. So it actually decreases surface attacks, and also it decreases the size of the image. So when there is a small size, it is very easy to run as a container, since its a startup time will be greatly decreased. So let's look at this Docker file. So in the first stage, where we are building the React UI, and then the second stage we are building the API. In the third stage, what we are doing is, you take the build from the first stage and you take the build from the second stage and put those assets and run, and we are creating the image. So in this way, there is a lot of node modules, obviously, when you are running any Node.js application. So this way you don't have to copy all the node modules, because your code is already built. When the code is already built, you don't need any node modules. So that way we can reduce the size of the image. So always follow multi-stage builds when you are running or building Docker image for any stack. So when you build the image, when you run the container out of that image, so you can run the whole application on port 3000, so that you can access the whole application on port 3000. So we will see that as a separate episode. And finally, there are a lot other things that we can do in this series, where you can actually we can see how to set up a PostgreSQL, we can see how to build an API, we can see how to configure PostgreSQL in API, and building UI, and how to make API calls, how to set up a development environment, how to Dockerize, how to linting, unit testing, integration tests, how to build for production. So there are so many things that we can learn in this series. So don't forget to subscribe, and thank you for watching.